In this video, we're going to take a look at the Unity editor and see how we will utilize it while programming future assignments. So let's just jump into the slides. So the Unity editor, let's go and look at what projects are. So a project inside of Unity isn't a single file, and that may be a weird thing to say right now, but anytime you create a project in the game engine of Unity, it creates a whole structure of folders. So let's see that in action real quick. And I've already got Unity pulled up here. So I'm just going to click on New. Whenever you open up Unity, it'll bring up this project launch window. And I'm just going to call this Chapter 1 Demo. And we're going to just store it on my desktop. It'll be a temporary game project. And we're going to go to Create New. And all those progress bars are Unity creating the files, the meta files, everything that's going to link together to form the basis of your game. And it'll take different times depending on how your machine's running, so just give it time. And whenever we say a structure of folders, that means we have folders and then folders within those folders, and then your assets or files will live there. And then metadata is something that we'll discuss whenever. Let me just set our view back to default here. So we can see we have a brand new Unity project open now. It's blank. There's hardly anything going on here. But I'm going to minimize all my notes. And we can see now we have a folder on my desktop called Chapter 1 Demo. And if we click into it, we can see that Unity has created all of these folders, different types of files. And if we click into assets, we see another subfolder called scenes. This folder will supposedly hold all of the scenes or levels in our game. And you can see something peculiar right here. Let me zoom in here. You see this scenes.meta? This is what we call a meta file inside of Unity. It's kind of like the way the game engine keeps track of folders and files, so it can direct the traffic and all the, I guess, instructions and commands going on in the game engine. So when we create a game engine, that's what we get. We get a bunch of folders and files. All right, let's keep moving. I mentioned scene already, and I mentioned they're kind of like a level inside of a game. They contain all the objects in your level. Scenes are only populated by objects. A project can have multiple scenes at a time. So let me show you those two concepts going on right here. So right here is our scene window. This is where we build our level. If I go to game object and create a cube, then boom. Now inside of my scene, I have three objects: the actual camera, the light source. You can see how the light source is changing the lighting in the scene, and a cube. This is a brand new object I just made. So scenes consist of these little objects here, and your scenes will be populated with a bunch of different objects as you get further along in development. So if we look down here to my project window, we can see that I have some folders already made for us, or the Unity was kind enough to do that when we made our new project. We have a folder called Scenes, and this little icon right here, I like to do my little slider down here at the bottom right. This will change the size of the icons. And I like to take mine all the way down so I can read the full name of the scene. So we have a scene right here with my cube, and I'm going to go to File, and I'm going to save my scene. So I just saved all my hard work there. And then I'm going to go to New Scene. And this time I'm going to put a sphere in the scene. And I'm going to call this, see, we have sample scene. I'm going to call this Scene 2. So now I have two scenes within my game project: my sample scene with the cube and my Scene 2 with the sphere. And whenever you make multiple levels of a game, or if a level needs to have multiple different environments, or you need to break it up somehow, you can link all of your scenes together to create all the levels of your game. So by default, only one scene is loaded at a time here. But you can actually open up a scene, and then you can have another scene with a few assets that you might need, and then load a little mini scene with the assets that you need into your big scene. That doesn't seem like it makes sense, but as you get into development and you see the the benefits of, I guess, having like a template scene that you can load into other scenes that contain the same kind of assets that you might need over and over again. It's kind of a nice way to organize stuff. All right. So why don't we talk about what objects are real quickly? You've already seen me mention a few objects. So our hierarchy is where all of our objects are going to be listed in our scene. And the next few slides that we're going to talk about is this system of hierarchy within Maya. So whenever we say that objects are the base class for all objects that Unity can reference, that basically means it's like the atom or the building block or the DNA of everything that will comprise your game. All right. And whenever we make public variables, say for instance, we want to make a whole number integer variable, and we create it to public, we can actually take our variables, which we'll learn about next chapter, and we can say, okay, we want you to be hidden from everything else, or we want you to become public. Basically, this says that objects have the ability to have their variables exposed as little numbers you can tweak inside of our hierarchy right here. So if I select my sphere, or rather, we can see our variables inside of our inspector. Whenever you see little check boxes like on the collider right here, we can collapse these other components. Is trigger is what we call a Boolean, a true or false variable. And that's all these are right here. All these little fields that we can tweak, they're just variables that are exposed to us and we can tweak. And it's kind of like a tool we can use to tweak the way our objects work in our scenes. Let's move on to components. And you'll start seeing a theme. I can't help but mention the next concept in our slides before we get to it, right? When I was talking about objects, I was talking about the components over here in our inspector, right? Well, simply put, and you might have already guessed it from context, components are these collapsible fields attached to our objects that basically act as little attribute fields for our objects. You can see we have a field for transform where we can move its position and rotation and scale. So I can make it extra tall if I wanted to, just by tweaking the transform component over here. You can also see we have components that render our geometry for us, our polygons, if you will. These two things handle our mesh, which is another term for polygonal mesh, is another term for, I guess, shell. Whatever you want to call a model at its very base form. And our mesh render is how we get lighting going, working on it. Do we want it to receive a shadow, for instance? Most of the time we want that on. Or how materials work, which are have to do with textures. We'll get in materials as we go along with our course. Oh, looks like I turned my sphere into a pancake. So one thing that you'll notice I mentioned earlier is that there's a system of inheritance or hierarchy attached with this. And you'll see that as we go along, there's another term I've already mentioned, game object. So a game object is basically just a level deeper down into the Unity guts. And really, you're safe to call anything inside your hierarchy an actual game object. They're objects, yes, but they're game objects in that they have a few special properties. Let's look at those on our slide here. So every game object has a name, an active flag, static flags, tags, layers, transforms. So what are those? What are we talking about here? Well, if we go to our game object folder or menu up here, let's just go ahead and create an empty game object. And you can see it just spits out game object to us. Let's just go ahead and delete that sphere. And whenever we zoom out and try to look at our game object we just made, there's nothing there. And if we look over here in our inspector, we don't have all those fields like colliders or renderers anymore. But what we do have are these default attributes, such as the name, test object. We can tag things. So if we wanted to enact instructions or code on the player, then we can set our player with a tag. And anytime we want to reference our player in our code, our tag easily lets us say, hey, everything with a player tag on it, this pertains to you. Listen up. You're going to do these things. We also have a layer system that not only acts as a way to lock and hide different elements within your scene, but they also act as ways to separate different objects in your scene. So if you had a raycast, like you were trying to get a target lock on something, so you shoot out a raycast, and whenever it hits first, gives you a value. It's kind of like painting a target with like some kind of weird laser weapon or something. Then we can say, okay, I want only these objects to be able to be targeted by raycast. Only the enemies or structures in this game can be targeted. So we can use layers to make sure that we're not raycasting on, a building or just a random prop in our level. We also have a transform component that will pretty much be on every single object no matter what in our game, and it's our basic position, rotation, and scale. So transforms is just a fancy way to kind of talk about, the physical properties or locations of a simple object there. So that's like the very base kind of attributes that all objects will have inside of our game. So anything that has more complex components on here, like on this bullet point here, and we can select something like that. Let's select our camera. And look, not only do we have a transform component over here in our inspector, but we also have this camera component, and pretty much we have all these exposed variables that we can tweak, right? Field of view, what the background color looks like, the depth. So a lot of things that are going to be a little bit above our pay grade, but just I want to reiterate that objects, the more components they have, the more sophisticated they become, and the more variables we can tweak on them, and really the more functionality they have, right? I mean, this camera has, lens type of attributes and an audio listener so it can hear sounds in the game world and report back to us. Really useful stuff. And game objects inherit from object, which basically means they're based on the same kind of DNA as an object, but a little bit more complicated. It's like a multi-celled organism rather than like a single-celled organism. So when we talk about inheritance, just think of it as like, what are you, a single-celled organism? What are you, just kind of like a really simple vertebrae? What are you, a fish? So as we walk up our hierarchy chains, basically that just means they all share some of the same common principles, but they get a little bit more complicated and have a little bit more functionality as they inherit more and more. So I think that's a pretty good metaphor for how inheritance works on a very general level. We talked about our transforms. This is the base component we have on pretty much every object in our scene, and that applies to our rotation, position, and scale. The only thing more I want to say about it, let's create another 3D object. Let's get a cube in here. If we want to mess with our transforms, yeah, we can tweak and click on one of the X, Y, or Z values here and then drag. But the easiest way to tweak these values is just to use our tools up here in the top left of our screen. You can see we have a move tool, a rotate tool, and a scale tool. And if you look at your keyboard and look at Q, W, E, and R, guess what? Q is your selection hand tool. W is your move tool, E is rotate, and R is scale. So that'll be the way we manipulate our objects in our scene, primarily the transforms of our objects in our scene. All right, let's keep going with our notes. Behavior. Behavior kind of dictates whether or not our components are going to work within our scene. So here's an interesting little demonstration. So you can see I kind of have, let me bring my cube over here more so we can see it. So I have my cube object right here, and then we have these check boxes, right? So if I click the the parent checkbox on the game object itself, so you can see this little square that kind of means, hey, this is an object. If I uncheck that, then basically my cube does not exist in the world or in reality. The reality of my game project, it does not exist, but I can check it to bring it back. That's turning on and off a behavior, but you can also do that on a per component basis too. So mesh renderer, if we turn off the mesh renderer, our cube still disappears, but yet other components are still at play here. We can see this evidenced by our box collider. See, I can still move my box collider around. And I can turn my box collider off as well. So behaviors are basically whether or not we want to use these components, and it is useful every once in a while to be able to turn a component on and off. Say, for instance, you want to turn off collision every once in a while on an object so it's not able to be hit by things. So mono behavior is kind of a big one here. Whenever we start coding things, then we're going to be calling on a lot of mono behavior here. And we should be really happy about mono behavior because it kind of gives us the transmission of our game here. It's like what the whole car is built on: the chassis and the transmission and the axles and all that stuff. It gives us a frame to work upon, and all these functions that we see right here have very important jobs within the game. The start function right here. Pretty much almost every script you make, unless special cases you don't need to do something on the very first frame in which the object appears in the game. But if you want to do code as soon as the object appears, then you're going to use the start function derived from mono behavior libraries. Or the update function calls this code every single frame. So if we see our box right here and we're trying to see if something is going to collide into it, remember we have our box collider here. So this green wireframe is like our invisible collision box. So the way we would use that would be every single frame we draw in the game, our FPS, our frames per second, every single time a new frame is drawn, we run code in our update function here, and we check and see if any object has collided with this wireframe. So every single frame you're seeing is just not a new frame forward in the animation of the game, but it's also checking collision, score, player input. Very important. So you can see that there are a lot of these mono behavior functions right here, and we'll look at most of them this semester and how they help us code. So without these, it would almost I wouldn't even know how to begin to code for the game if we didn't already have these kind of functions rolled up for us. That's when you start talking about software engineering your own game engine. But the good thing about Unity is it's done a lot of that heavy lifting programming for us. So not only does it have a function that does code every single time the frame is drawn, we also have other tools in there like physics engines, audio engines, really a lot of good stuff that the game engines take care of for us. So I've been talking about inheritance and hierarchy. So let's look at kind of like some family trees here. You'll notice everything starts with an object, right? So we can either go the game object route, which kind of just points at the actual particle system or the model or whatever asset you have in there, and not really worrying about the properties of it. And you'll notice if we want to start looking at the components or the transform of an object, we kind of just skip the whole game object thing and go, hey, where's that object? I don't care about, the next layer. I want to go straight to the properties of that object, and I want to look at the transform. So we start with a single cell, we get a multi-cell organism, and then we got a real simple invertebra with, the transforms. So it's like, the caveman walking and slowly turn into like a Homo sapien, right? And then it gets even crazier. If we want to create a custom behavior, like a collision box for a cube right here. So we want to have the behavior of this collision box working. We look at the object, we look at the components, which are all these little drop-down menus right here in our inspector. And then we look at the behaviors in them, which is this actual field right here. And then we look at the mono behavior, the actual code, the transmission, the chassis of our script. And we kind of get more and more sophistication. Then we start looking at, hey, look, I can turn on is trigger, or change the size of the box here through my develop code right there. So, it's just systems built on systems. Prefabs, one thing we'll say about prefabs is they act as like a template for a game object. So, let's get rid of that. Let's say we want to build like a really simple looking torch. So I'm going to bring back my cube, and we're going to scale it. And this is going to be the worst looking torch ever, but it's going to really get the idea across. And we're going to make a sphere. You know what? We're making a lollipop. That's what we're doing now. So whatever. Who needs a torch when you got a lollipop? So I'm going to put the lollipop together. And then with my empty game object here, I can create a hierarchy of objects and have a parent and some children. And I'm going to go over here into my transforms and reset my empty game object. So my empty game object is located at the center of my screen here. I'm going to do that for all this. Oh, that messed up my transforms. So transforms are a funny thing sometimes. But never fear, I know how to use this program pretty good. I can rebuild it real quick. All right, that's not a lollipop anymore. There we go. And then what I can do is I can take my sphere and cube, highlight them both, drag and drop. Let me zoom in here on what I'm doing. I can take my cube and drag and drop it on game object. Sphere, drag and drop it. Single click game object now and call it lollipop. And now, anytime I need to use a lollipop, maybe in this scene or another scene, I'm going to come down to my assets folder, or right here inside of my project window. I'm going to right click in some empty space, create a new folder. We're going to call this Prefabs. And then I can take my lollipop and drag it down right there. And now you see that my lollipop in my hierarchy is blue now, and I can delete it. And anytime I'm going to bring my lollipop back in the scene, or maybe heck, let's go into scene 2. Let's not save that. Look, I can bring my lollipop into scene 2 now. It's like a little template for us. Prefabs have a little bit more functionality than just being a template, but that's how we create them, and that's how we can use them on a very basic level. Mono behavior, I think this needs to actually be called naming convention. But one thing that we want to discuss is naming conventions for scripts in our game. I'm just going to go ahead and we'll learn how to create scripts next chapter and start working in them. This is kind of like an introduction. Like I said, this is some basic concepts. So I'm going to create a new C# script, but we have some rules. There should be no spaces in the name of your script. There should be no special characters other than an underscore, and it cannot start with a number. So let's make the worst script name we can think about. So we're going to call this 1, and then do a space, and then be like, hey boy, with an exclamation mark. And that right there, everything looks fine, but That's got to be the worst name of a script ever. It breaks the number in front, it breaks the space, and breaks the exclamation mark. So this would be how we do this. This is how would be how we would make a script name. We would go hey boy _1, and that is a perfectly fine script name. Maybe. I mean, I guess you would need hey boy too, so you can just do a duplicate. Oh, there. Oh, nice. As soon as I pressed Control D, it went ahead and counted up for me. That's good guy Unity for you. We're seeing something real crazy though. I'm going to go ahead and delete this. So I changed my name of the script to HeyBoy1, but if we go and look at its preview over here in my inspector, so if I select the script, my inspector becomes kind of like a preview over here. You can see if we look at, let's ignore these little engines or these library calls right here. And let's look at the 5th line of the code here, and it says public class, new behavior script, mono behavior. New behavior script is the name we have on default scripts. And whenever we called our new script HeyBoy1, then we changed the name of our script, and now if we try to press play, let's see. I'm going to attach hey boy to lollipop. But we get an immediate error in that we can't call back. It needs to derive from on. So it's just not happy that the name of the script HeyBoy1 does not match the name of the class new behavior script. So whenever you're making classes or scripts or classes kind of interchangeable. Be sure that you don't really change the name or you update that over there. So that's going to cover it for some of the most basic concepts for actually using the Unity game engine and how it pertains to programming. So we're going to go ahead and end the video.